Hello, welcome to Master Algebra with Simeon. I'm happy to have you here. Today we're going to learn the basics of solving algebraic equations. So by the end of this lesson, you'll know exactly how to solve such problems like a pro. So let's begin. Let's assume that we have these three sets of equations. So basically what you're going to do is to find a solution for algebraic equations with three variables, different variables. So in this case, let's assume we have this equation x plus say 3y plus 2z is equal to 25. So that's the first expression. And the second one, let's have something like 3x plus 2y plus z is equal to 22. Then the last equation, then the last equation is have 2x plus 2y plus 3z is equal to 29. So this is an example of algebraic equations with three different variables x, y, and z. So in this case, we are supposed to find the values of x, y, and z. So given these equations, the first thing we can do is to isolate x from the first equation. It's easy from the first equation to isolate x without having fractions. So basically, that's where to start from. You scan through the sets of equations and check where you can easily isolate one of the variables. So let's have this, the fourth equation as. So if we have to make x the subject of our formula here or expression, then we would have x is equal to 25 minus 3y minus 2z. Okay, so basically that's the value of x. Now the next step, we would need to substitute x in the second equation. Okay, then we will do the same in the third equation so that we reduce the number of variables from 3 to 2. So with two variables and two sets of equations, then we can easily find the values of y and z. So let's go. Let's first substitute the value of x in our second equation. So in this case, it will be 3 in bracket, then we input the value of x there, which is 25 minus 3y minus 2z. Okay, now that's our x, and now we write out the remaining terms of the expression. So in this case, we have plus 2 y, then plus z, and this one is equated to 22. Okay, now we can simplify this one further. So 3 into 25, that's 75. Then we have a minus here, so we say minus, then 3 times 3y, that's 9y, 9 y minus 3 into minus 3 into 2z, that's 6z. Okay, so basically what we've done is to open this bracket here. So this 3 times 25, which is 75, then take note of the sign of this one, 3. So then it's minus, then 3 times 3 is 9y, then again minus, then 3 times 2, which is 6z, sorry. Then you say plus, no, we add the other terms, 2y plus z is equal to 22. Okay, all right. Now the next step is to collect all the like terms together. So let's start with 9y. So we would say basically minus 9y minus 6z. Okay, sorry, minus 9y, then plus 2y. All right, then now we can come to z, minus 6z plus z is equal to 22. Now we bring this 75 to the other side. Okay, so we pair it with 22. So 75, once it crosses the equal sign, then it becomes minus 75. All right, okay, now you see we have minus 9y plus 2y minus 6z plus z is equal to 22 minus 75. Okay, let's solve it further. So this minus y plus 2y is minus 7y, then minus 6z plus z is minus 5z. All right, then that is equal to 22 minus 75 is minus 53. All right, now since we have minus 7y minus 5y is equals to minus 53, we can simplify this one further by removing these minus signs through we just need to multiply by negative 1 through. So if we multiply by negative 1, let me put this, let me use angle brackets, or it's just fine. Let me say minus 1 minus, sorry, it's minus 1 in bracket, say minus 7y minus 7y, then minus 5z, okay, is equal to, this one is equal to, remember we were multiplying through by negative 1, so again I do that, is equals to minus 53, right? So if I open this bracket now, right, then I'll have 7y plus 5z is equal to 53. Okay, all right, so equation 10 gives us the expression for equation 3, sorry, with two variables because we have substituted x. All right, now the second step is to substitute the value of x, the expression for x, in the third equation, this one here. All right, so what basically we're going to do is we are going to write equation 3 with the value of x substituted as so. You see 2, because this 2 here, right? Then in bracket, now we input the value of x, this one, alright? Because we say x is equal to 25 minus 3y minus 2z. So this, we are substituting it here just the same way we did for the second equation, where we substituted the value of x as such. So let's go. Now, we'll say 2 in bracket, we put this 25, alright? Then minus, minus 3y, okay? Then minus 2z, like that. Alright, now basically what we've done is we have substituted the value of x with this expression here. Then we continue with the other terms. We say plus 2y, this here, 2y, alright, then plus 3z, like that. So this 2y plus 3z, then we say is equals to 29, this. So we say is equal to 29, okay? Now, let's open the bracket. Can you do this before can you try doing this before I finish? So now this is 2 times 25, which is 50, minus 2 times 3, which is 6y, okay, 6y, then minus 2 times 2z, which is 4z, right? Then we say plus 2y plus 6z, okay, is equal to 29, right? So you can just check through. This is 25 minus 3y minus 2z. So if you multiply by 2 through, you get 50 minus 6y minus 4z, then plus 2y plus, sorry, this is not 6, supposed to be 2y plus 3z, alright? So 2y plus 3z is equal to 29, okay? Having done that, we need to collect the like terms together, just the same way we did previously. So we'll start with minus 6y. So this is minus 6y, okay, plus 2y, plus 2y, 6y, then plus 2y. Then we take 4z now. So we say minus 4z, okay, alright, plus 3z, right, plus 3z, you see? So this is 50, now is equal to, then we say 29. So this 50 crosses the equal sign to the other side, because we are simply collecting the like terms together. So 29 minus 50, okay, alright. So it's minus 6y plus 2y minus 4z plus 3z is equals to 29 minus 50. Let's simplify further. Minus 6y plus 2y is minus 4y, alright, minus 4y, then minus 4z plus 3z is minus z, okay, then is equal to 29 minus 50 is 21, right? Yep, minus 21, sorry, it's minus 21, like that, right? So doing the same thing that we did the previous time. You remember here, when we multiply through by -1, so to make everything positive. So I don't need to show this step now. What I'm going to do, I'm just going to multiply without writing. So this is going to be 4y. If I multiply through by -1, it's 4y plus z, alright, plus z is equal to 21. Okay. Now you'll realize that equation 15 and equation 10 have two unknown variables, y and z. So what we need to do now is to solve the two to find the value of y and the value of z. Then we will go back to the expression for x. Remember this one, to find the value of x. Alright, so let's go. Now we have let's start with equation 10. We'll say 7y plus 5z is equal to 53. Okay, 7y plus 5z is equals to 53. And then we have this other equation here, 4y plus z, okay, is equal to 21. Alright, look at them. Are you seeing? 7y plus 5z is equals to 53, and 4y plus z is equals to 21. So in this case, we can use the elimination method. Alright, so if we look through the two equations, you will find that we have 5z here, and here we have z. So it's easy to eliminate z because we'll only need to multiply equation 17 multiply through by 5 to make z, to have z get a common number, kind of. Okay, yep. So if we multiply through equation 17 by 5, we will get 20y. Alright, that's 4y times 5, which is 20y, plus z times 5, or 5 times z, whichever you want to put it, it will be 5z. Alright, is equal to, then 21 times 5 will be 105. Okay, the idea is to make z, alright, have a common factor. Okay, in this case it is 5. See, okay, this, look at equation 16 and look at equation 18. Now it will be easy for us to eliminate z. Let's have them side by side. So now I have this. Let me bring equation 16 to become equation 19. Let me just write it. 7y plus 5z, okay, is equal to 53. Alright, now you see 7y plus 5z is equals to 53. So now we can eliminate this one. So we'll say we are basically going to subtract each term, okay, each like term. So in this case, I will have 20y minus 7y, okay, 20y minus 7y, 13y is equal to, now since our aim was to eliminate z, we have successfully achieved that, because we're going to say 5z minus 5z, that's 0z. Then we're going to say is equal to 105 minus 53, okay, which is 52. You get the concept? All right. So in this case, we are going to divide through by 13. All right, 13y is equals to 53. So divide by 13, divide by 30 to get the value of y. Let me just show it. Let me see if I can get fraction. Yeah, nice. So I'm going to say here, I'm going to say 13, okay, over 13, okay, y, all right, is equal to, let's not get another, get this here, is equals to 52, this one, over 13, okay, you get the concept? All right, then if I cancel here by 13, 1, by 13, 1, then I get y is equals to, what is 53 divided by 30? How many times that 53 goes into, how many times does 13 goes into 52? Okay, I guess you're right. This is 4, right? So now y is equal to 4. All right, so now you've got the value of y. So to get the value of z, you can use any of the equation here, our two equations that we had. Either you can use this or you can use this to get the value of z. So which one is easier? Let's use this. 7y plus 5z. Sorry. Either you can use 7y plus 5z equals 53, or 4y plus z is equals to 21. Again, you can choose any, but for me, I choose to go with the easier one. This 4y plus z is equals to 21. So here, I'll substitute y to get the value of z. So I'll say 4 in a bracket, what's the value of y? Here. This is the equation that I'm trying to substitute the value of y to get the value of z. So my y is 4. Okay? Is equal to, now, before that, I would say 4 into 4 plus z is equal to 21. Alright, you see, I have substituted in this equation. Alright, so this one is going to be 4 times 4 plus z is equal to 21. 16 wait, something's off. Yeah, okay, so it's fine. So here is 16 plus z is equal to 21. Alright, so then this means z is equal to 21 minus 16. Z in this case is equal to 5. Okay, you get it? This, what I've done is Having found the value of y, then I went back to this equation here, this one. Okay, 4y plus z is equals to 21. Then I substituted the value of y because y is 4. Okay, so it's 4 times 4 plus z is equals to 21, which is here. Now, this translates to 16 plus z is equals to 21. So then it implies that z is equals to 21 minus 16. Then z is equals to 5. Alright? So now we have the value of y and the value of z. You remember our first equation where we isolated x? This one. Alright? So what we need to do is to now substitute y and z to find the value of x, and we'll be done. So let's rewrite our expression for x. X is equals to 25 minus 3y minus 2z. Okay. So here we need to say x is equals to 25 minus 3y minus 2z. You get it? It's here. It's here. Our first equation, the one that we isolated x, this 25 minus 3y minus 2z. Okay, now to get the value of x, we'll have to substitute y and z. So it is 25 minus 3 into bracket. What was the value of y? It was 4 minus, what was the value of z? It was 5. Okay, alright. So now this one is equals to 25 minus 12 minus 10. Okay, so x is equal to so this one is 25, not 15, sorry. Alright, so now x is equal to 25 minus 22. Alright, x is equals to 3. You get the concept? So in this case, our answers are x is equals to 3, y is equals to 4, and z is equals to 5. Y is equals to 4, z is equals to 5, and x is equals to 3. We can actually prove these answers. We can check if these answers are correct by substituting the values of those variables into one of the equations to see if the left side of the expression is equal to the right side of the expression. Okay, we can pick this first equation, this x plus 3y plus 2z is equals to 25. So let's substitute the values of x, y, and z to see if they sum up to 25. Alright, so let's go. X plus 3y plus 2z. Okay, so here we have x plus 3y plus 2z is equal to 25. Right? Now we need to check. X is 3 plus 3y, y was 4. So 3y should be 3 dot 4. Oh, let me use mathematics, elementary mathematics language. So it's 3 plus 3 into bracket, our y is 4. Alright, then plus 2 into bracket, what is our z? What's the value of z? 5. Okay, now we want to check if this sum equates to 25. If it does not equate to 25, then that means our values are wrong. Okay, let's go. So this is 3 plus 3 times 4 is 12 plus 2 times 5 is 10 is equal to, this is 15 plus 10 is 25. Okay, so 25 is equal to 25, meaning the values that we have found for the three variables are correct, and therefore the solution is correct. So that's how to go about it when you are given three algebraic expressions with three different variables. Let me know if you have any question. The next time when we meet, we will solve the same problem using matrices. For now, drop me a comment, tell me where I can assist or where I can improve. Bye.